So we're talking about simple trinomials. First of all, tri, like the word tricycle, triangle, means three, right? It means it has three terms. So we're dealing with an expression that looks like this. For example, that's number 1 from your assignment. The terms being here, here, and here. So terms are usually separated by a plus or a minus sign, adding or subtracting. Now, what makes this simple is because there's no number written in front of the x squared. I'm not saying that there is no number. I'm saying there's no number written, because if there's no number written, we assume or we know that there's actually a 1. So this is a simple trinomial, and now we're going to factor it. So how we do that is using one of 3 methods. The first method is a reasoning method. We do this by drawing an x. Ms. Cantillon usually does that method. I don't think Mrs. Edwards uses the x, but the reasoning is the same. We look for 2 numbers that multiply to 5 and add to -6 in this example. Now, where does the 5 and 6 come from? 5 and -6 come from? Well, you've seen this before. The 5 comes from here, and the 6 from here. When we talk about the 5, we usually call that the C term. And when we talk about the -6, we usually call that the B. If on the side here I'd write that down, this is how we usually write simple trinomials. X squared plus bx plus c. So you can see that form here. Okay, so we have what multiplies to +5 and adds to -6, 2 numbers. And if you can't think of them, we sometimes write down, okay, well, what are numbers that multiply to 5? 5 is easy, right? There's only one set, a 1 and a 5. If we want them to add to -6, we realize this must be a -1 and a -5. And now that we have those 2 numbers, this here and this here, we can write the factors of this trinomial. We know then that the factors are going to be x, here's the first number, subtract 1, multiplied by x subtract 5. Okay? And we can easily check that by doing FOIL, multiplying it out. So x times x gives us x squared, x times -5, -5x, -1 times x is -x, and -1 times -5 is +5. If we group these 2 like terms, we have x squared minus 6x plus 5, which is exactly what we started with. That means we did this correctly. The second method is the tile method. Do you remember algebra tiles? Okay, so we have the first tile, this is the x squared tile, meaning that its dimensions are x wide and x high, right? Length times width. The second tile is an x tile, meaning its dimensions are 1 wide and x tall, so that the area is x times 1x. And this is a 1 tile, meaning its dimensions are 1 by 1, so its area when you multiply that is 1. Okay? So, if we have in this case, if we want to factor x squared plus 3x plus 2, we've got one x squared tile. We've got 1, 2. Now remember that I'm trying to arrange this to make a perfect rectangle, right? So I'm going to turn this over. I know I only have 2 1s, so I need 2 spots there. And now we have 2 1s, so we've got this one and this one. Okay, so once you have your tiles arranged, then let's figure out what their side lengths are. So this big tile is an x squared. its length was x by x. And then we have this x tile. It has a width of 1, and the second one has a width of 1, right? I might as well just write a width of 2 here for those two added together. And then on the left here, that has a length of 1. So now this width, or the height, I guess we could say, is x plus 1 when we add those two parts together. And our length times width would be, in this case, x plus 2. I'm getting a little squished together there. So I can know that this factored is x plus 1, that length times the width gives us this whole multiplied together part. That was the area inside. So that's factoring using algebra tiles or tiles. And the third method is the area method. Let's do that one next. Let's look at question number 2 from your assignment to remind us about the area model. So the area model looks like this. I think it's similar to the tile method where we're drawing a picture of what the area might look like. In this picture, the top left box is going to be our x squareds, and we have one of them. And the bottom right box is always our constant term. In this case, it's a 12. Now, these diagonal boxes need to be add up to -8. So on the tops of the columns and on the beginnings of the rows, we're looking for the column heading. Now this heading, or what multiplies to this area, is going to be x times x. In simple trinomials where this is always 1x, this will be true. X times x gives you this area inside, x squared. And now we have a couple different options for the column and row headings to multiply to 12. We could have a 1 times a 12. We could have a 3 and a 4. We also could have a 2 and a 6. Now what I put in there, I want to try to make sense. Well, it has to add to -8. So again, we can go back to our very first method where we used reasoning and we used that x, and we asked ourselves, okay, something that multiplies to 12 and adds to -8. Well, I think -2 and -6 would work. So again, I am doing this reasoning idea using this area model. But now if I fill in the inside of my chart, I'm going to say that -2x goes here and -6x goes here. And together we are remembering that this has to add to the -8, right? Okay. And so now I can figure out my column headings. I think, anyways, x has to be multiplied by -6. So -6 times x gives me the -6x, and here x has to be multiplied by -2. That works. Now let's see here, -6 times -2, yes, gives me +12. So that would work. So now, let's get rid of that reasoning. From there, now looking at the blue parts, I can see that this expression, or this simple trinomial factored, would be, I'm going to write down the column headings first, x minus 6, multiplied by the row headings, x minus 2. It doesn't matter when you multiply which factor goes first. So I could have done row by column. Okay, so that's the review of 3 methods. I'd like you to proceed to your assignment and make sure you fill out your flip book.